everyone. My name is Rajesh Kumar Singh. I am a member of Team-9, and the course project that we were assigned was Extreme Climatic Event Analysis using Extreme Value Distribution as a part of our course Statistical Foundations of AI and ML term project. So these are our team members, and basically what we have tried to do in this project is we have carried out an extreme event analysis on a set of climatic data that we have gathered from the internet, and we have carried out some study on it. So let us see what we have done in our project. So we have carried out our project in four parts. The one is data creation and visualization part. Second is region-wise GEV analysis. The third is block maxima and point above threshold methods. And then we have tried to fit it our data set on GEV and Pareto distribution. So let us see how did we create it and visualize our data set. So we gathered the data set available on the internet from a time period of 2000 to 2023, and you can download this dataset by running this code snippet. For the first time when you download, for the first time when you run this dataset, you need to uncomment this part of the code, and then you will be able to download. And then just uncomment this so that this downloading doesn't occur more than once. So once you do this, you will have the dataset available in your directory, in your drive folder. Just like this, we have in our dataset. This is all the GRD dataset that we have downloaded from the 2000 time period to 2023. So GRD is a data type that is being used to store the climatic data, and then we have converted the data from GRD format to the CSV format for our own convenience to carry out the studies that we are going to do. So first we downloaded this data for this time period. Then we tried to visualize this data for the respective time period. And these are the respective longitude and the latitude ranges. So our longitude ranges from 67.5 to 97.5, and our latitude ranges from 7.5 to 37.5. And these are the intervals on a 1 degree basis. So basically, if the least value of the longitude is 67.5, then the maximum value is 60. Then the second lowest value will be 68.5. Then the next value will be 69.5, and so on. Similarly, for latitudes, the minimum value is 7.5. Then the next value will be 8.5, and then 9.5, and so on. So this is how our data set will look like. The latitude and longitude pairs in it will look like. As you can see here as well, for the latitude 7.5, we have longitude at 67.5, we have longitude 68.5, then we have longitude 69.5, and so on. Then we filtered out the data set according to our need for the maximum temperature data set and the average maximum temperature data set we also took here. And then we saved it so that we can use it. Once you save this data set, all the four parts of this code are independent from each other, because then we have directly loaded the data set from the drive, and then you can directly use it, even if the main data it is what you need, or the raw data it is that you need. You can, once you save the data set, you can use it in any order independent from each other. So you would need to save it once in your drive, and then you can use it. So after filtering the whole data set, we tried to visualize it on the map of India. So what you can see here is a small region which is representing the latitude and longitude value, pair value of that specific point. So this is a point where a specific latitude and longitude pair lies. And the intensity of this dot shows basically the temperature of this the mean maximum temperature of this region throughout the time period from 2000 to 2023. So this is what we have tried to visualize in this figure. So these, each and every this dot represents a pair, which means, as I said, the minimum was 7.5, and then corresponding pairs were 7.5, 67.5, 7.5, 68.5, 7.5, 68.5. Similarly, For 8.5 will be 67.5, the 8.5 68.5, 8.5 69.5, and so on. So these are all those pairs. And then we filtered out all the pairs that lied outside this region. So basically outside this region, the temperature value would have been 99.9. And then we filtered out according to our need, what we want and what we don't. So that is why you can see uh, a slight boundary around this Indian map region, after which there is no point that you can see or that you can point out. So this was the data creation and visualization part of our code. Then we have tried carrying out the region wise GEV analysis. So what we have done in this method is we have uh, we have first prepared all the possible latitude and longitude pairs that are there for our data set. The minimum will be 7.5, the maximum will be 37.5 latitude. And for longitude, minimum will be 67.5 and the maximum will be 97.5. And then we have carried out the GEV analysis. So this code basically performs an extreme value analysis on maximum temperature data for a specified region and time period to study both upper and lower threshold ranges. Uh, it it begins by filtering the data based on latitude and longitude and year, then calculates the threshold to identify the extreme events. So basically, this GV distribution is fitted separately to the upper and lower extremes, and the model's parameters are used to compute expected versus actual numbers of extreme events for each year in a surrounding region. Visualizations created from this work include histograms, QQ plots for model validation, and return period versus return value plots to analyze the likelihood and intensity of extreme events. So, this analysis basically provides insights into the frequency and behavior of extreme temperature and events for climate studies, respectively. So as you can see, uh, once we are done with this function, we are running this on the complete region list that we created. And then it is generating the plots, respective histogram plots, the expected versus actual number of extreme event plot, and the QQ plots for the upper and lower extremes as well. So this is for the upper distribution. Then we have respectively for the lower distribution as well, as you can see here. And then for the next region, it is carrying out the same study. And similarly, we are carrying this out for all the regions, all the possible regions in our data set. So this was region-wise GEV analysis. Then we have tried carrying out the block maxima and point above threshold method. So in this, what we have done is we have tried using block maxima and point above threshold methods to visualize the data set. So this is basically the maximum temperature data set on each day. So you can see that temperature variance is very high. The temperature may decrease up to zero or might be negative in some cases. It might rise up to a very extreme temperature during a year. So this is basically all those peaks during all those years, and then we have tried fitting the data. So this is basically the similar graph for the maximum temperature. Then these are the respective QQ plots and PP plots for our data set. This is the respective maximum temperature and the return period plot for our data set. This is the mean excess versus the threshold plot for our data set for the maximum temperature. So this was the block maxima and point above threshold method. And then we have GEV and Pareto distribution that we have tried to fit in for our data set. So this code basically analyzes extreme temperature events by fitting statistical models to temperature that exceed a certain threshold. And that threshold that we have set is 40 degrees Celsius for our data set. So it loads and processes the data set for our maximum daily temperature. So here we have loaded the data set from the drive itself. and then it fits the GEV and Pareto distribution on our data set. It then generates visualization, including the probability density functions of the fitted distribution and a histogram of the observed data to validate the models. So this analysis will help us in understanding the behavior of extreme temperature events. So that's what we have tried to carry out in this part of our study. So this is what we have tried to fit the GEV distribution, and this red graph is the temperature data set that we have tried to plot in this graph. Then this is the GEV distribution for the temperature data. This is the GEV distribution for excesses data. This is the Pareto distribution for our excesses data. You can see the histogram goes like this, and the Pareto distribution is like this. So we have tried to fit as much as possible in our data set. And this is the temperature histogram over the period throughout the years, and the temperature is in degrees Celsius in this plot. So this is basically a summary of what we have done. I hope you like it. Thank you.